Hello everyone, my name is Jerome McFarland. I'm VP of Marketing at Elastifile, and today I'm going to be discussing cloud integrated rendering and transcoding and explaining how Elastifile can help you burst these data-centric workflows into Google Cloud. Now, as many of you may have experience with, rendering and transcoding jobs can generate some very demanding compute and storage requirements, particularly on the compute side. And these requirements can tend to saturate the resources that you have available on premises. And when those resources become saturated, it can become a critical bottleneck to the completion of your media pipelines. Now, for all intents and purposes, you can consider your on-premises resources to be constrained. And by constrained, I mean that they're limited essentially by the available hardware, the physical infrastructure that you have available in your on-premises environment. Now, of course, in Google Cloud, you have these elastically scalable resources that you could leverage to accelerate and expand the abilities that you have on premises. Now, cloud integration is solving some critical IT challenges, right? One of them is providing elasticity, right? In the cloud, resources can scale elastically to match the bursty workload requirements of your rendering and transcoding jobs. In the cloud, you've got essentially unlimited performance. The resources in the cloud are effectively infinite and capable of high degrees of parallelism. And the cloud also helps you to reduce complexity. And the IT as a service abstraction layer provided by the cloud essentially eliminates a lot of the IT headaches that you may be dealing with today. Things like hardware upgrades and maintenance, things like CapEx-centric commitments for infrastructure purchases. You can get rid of all that in the cloud, as of course the hardware is abstracted away, and you're dealing with much more flexible OpEx-centric models of managing your infrastructure. So you've got this cloud with elastically scalable resources in GCP, you've got these constraints on premises, so then the question is, how do you tie the two environments together? How do you burst? How can you do that? So when we think about cloud integration, I really think about three different aspects to a checklist. One of them is delivering scale, performance, and simplicity. Another is making sure that your applications, so in this case your rendering and transcoding apps, that those applications that you're running on premises, that they can work seamlessly in the cloud without having to refactor those applications or refactor those workflows. And a third key criteria for cloud integration is ensuring that you can efficiently and effectively manage your data, both getting it from point A to point B, from on-prem to the cloud, and also managing it efficiently and effectively within the cloud to ensure the proper balance between performance, capacity, and also cost. Now, when we think about the scale, performance, and simplicity, that's what Google Cloud delivers, right? As we talked about before with the elasticity, the performance, and the reduced complexity, that's what you're getting from the cloud. So what about the other two aspects, making the applications work seamlessly and efficiently managing the data? Well, that's where Elastifile comes in. So what is Elastifile? What do we do? Elastifile augments public cloud capabilities and facilitates cloud consumption by delivering enterprise-grade scalable file storage in the cloud. So why is file storage important? Why is this a critical aspect of a bursting workflow? Well, when you think about what you're doing when you're trying to burst the workflow to the cloud for rendering or for transcoding or for any compute-intensive job or process, what you're effectively doing is leveraging scale-out compute resources in the cloud, right? You're spinning up those applications, but you're feeding them with much more CPU than what they have available in your constrained on-premises environments. So those applications, they need to process something. That something is the data. They need to access the data somehow. So how are they going to access the data in the cloud? On top of what? Well, when you think about cloud, the first things a lot of things people think about is object storage. But when you think about the applications that are performing rendering, that are performing transcoding, some of these intensive workflows, those applications typically actually weren't written to interface with object storage. When you think about it, file storage is actually the data foundation for media pipelines. Whether you're dealing with the raw assets, the edited and rendered assets, the transcoded or packaged assets, these assets are being managed within file systems and on file storage. And these media applications are really expecting file interfaces. They're expecting to create and ingest file and directory structures. They're expecting standard protocols, file system protocols like NFS, and they also need strict data consistency and the ability to share data. And they also need the performance that a file system can provide when compared to something like object storage. So if these applications are expecting file systems and running on file systems on premises, why not give them a file system in the cloud? And that's what Elastifile is doing. We're providing these applications with a scale-out, high-performance distributed file system so they can run seamlessly in Google Cloud without having to change those workflows, without having to refactor those workflows or applications. When we do that, by leveraging something called the Elastifile Cloud File System. This is what we provide. It's a software-only, environment-agnostic, scale-out distributed file system that runs in Google Cloud. And essentially what the Elastifile File System, which we call ECFS for short, essentially what it's doing is it's aggregating storage resources provided by the GCE compute instances. So those hard disks, those SSDs attached to the GCE instances, we're aggregating that storage capacity and presenting it as a single namespace to the applications that are running in Google Cloud. And that namespace is presented as a POSIX-compliant file system. So then those applications can run just as they ran on premises without having to be changed or having to be refactored. Now, ECFS was built for the cloud from scratch. It's got a fully distributed services model, including distributed metadata management. And as many of you may know, if you've dealt with storage for media workflows in the past, metadata management can often become a bottleneck to the performance of those file storage appliances on premises. Our solution was built with fully distributed metadata, so we don't have those types of bottlenecks, and we can support performance at scale in the cloud. We also have scalable capacity and performance in that you can add or remove capacity from Elastifile as necessary to provide basically a right-sized storage solution to match the requirements of your workflow at a given point in time. Full enterprise feature set, including snapshots, data reduction through compression, deduplication, and high availability and data protection features to ensure that if something were to fail, like a device were to fail on your cloud VM, or if the VM itself were to go down, you won't lose data, and you also won't lose access to the data, right? We have enough redundancy to prevent that. We also have REST API controls, so everything that you can do through the Elastifile UIs, you can also do through REST APIs to provide automation, leveraging things like infrastructure as code via Terraform or Ansible as examples. And also you can deploy Elastifile with a push of a button through the Google Cloud Marketplace. You can go to Marketplace today, search for Elastifile. You can say, I want to deploy 500 terabytes of storage on SSDs for my transcoding workflow. Press the button, we'll spin up the associated infrastructure seamlessly in the background and present your applications with an NFS mount point so they can interface with that storage in exactly the same way that they would interface with a storage appliance on premises. But now leveraging all the scalability of the cloud and all the ability to apply additional CPU and memory resources to get those jobs done more quickly. So when we think about making the applications work more seamlessly without having to change them or refactor them, going back to our checklist, I think we've got that covered. We've given them a POSIX-compliant file system, which is exactly what they're expecting. So what about the final criteria? How do you efficiently manage the data? How do you get it from point A to point B? And how do you manage it efficiently in the cloud? Well, we have a solution for that as well. We have something called Elastifile Cloud Connect, which effectively enables bidirectional transfer of data between file and object storage and really blends the best of both worlds for file and object in both hybrid and in cloud use cases. And when we talk about hybrid workflows, really what I'm talking about is the transition or movement of data from on-premises into the cloud. So with Cloud Connect, what we do is we can take data from any file system. It could be an Elastifile file system on-premises, but it doesn't have to be. It could be NetApp, it could be Isilon, doesn't matter. We take data from any on-prem file system, we'll encode it into object storage format, so we'll encode it into GCS format, and we'll place that into object storage in the cloud. Right? Then, once you're ready to actually process the data in the cloud, you can spin up the Elastifile Cloud File System, and Cloud Connect will also allow you to rehydrate that data from object storage back into file format. Now, when we move this data from file to object and back from object to file, we're always retaining all of the file and directory hierarchy information, all the attributes, all the links, all the file system information, so you don't lose any of that metadata or any of those relationships that you had on premises. We also are very efficient about the transfers. We dedupe and compress the data before any of the transfers, and after an initial data sync, let's say you move some data from file on-prem into object on GCS, after that initial sync, if you make more changes on-prem and you want to synchronize the data, we're not going to copy the entire data set over again. That wouldn't be efficient. We're just going to send the changes. So we're very efficient to minimize WAN costs and also to maximize performance. And just like ECFS, everything you can do with Cloud Connect is controllable fully through REST APIs, so you can implement fully automated workflows. So if we think about an end-to-end workflow to burst rendering or transcoding jobs to the cloud, what does that look like? So first thing that you would do is you'd stage the data in GCS using Cloud Connect. So we'll take that on-premises file data, we'll encode it into object storage, and although in my demo that I'm going to show in just a few minutes, we're going to just do one on-premises file system to one GCS bucket, you can actually stage data from multiple locations, from multiple users, from multiple sites into object storage. And once you're ready to actually perform your transcoding, your rendering, or whatever processing you want to do in the cloud, then you can spin up the associated infrastructure for compute and storage. On the compute side, it's going to be GCA instances running whatever applications that you're leveraging for the workflow with as many compute instances as you want. And on the storage side, it's going to be Elastifile file system scaled to whatever capacity you need for your workflows. Then when you're ready to perform your render your transcode job, you can check out the data that you want to render or the data you want to transcode into the file system, and then you can go. And once you're done with the rendering or transcoding, you can pull the data directly back on premises, or if you'd like, since Cloud Connect is bidirectional, you can actually push data back into GCS and save it for later use. And when you're done, you can spin down the Elastifile infrastructure and all the compute. So you only pay for that infrastructure when you're actually using it. And then later, if you decide you want to re-render or re-transcode, you can spin it up again, check out the data again, and go for it. So that's at a high level the workflow. And the efficient data management piece, as we just discussed, handled by Cloud Connect. So now I'm going to show you a quick demo to illustrate kind of a real-world example of what I just described. So in this demonstration here, you can see this is the model that we're going to burst to cloud and we're going to render. The first thing we're going to do, though, is we're going to render it leveraging constrained on-premises resources, right? In our on-prem environment, we're going to create a 3-node render farm with 12 CPU cores, and we're going to measure the real-world rendering time to execute this job. And then we're going to compare that to the execution time for an end-to-end flow. We're going to start by staging the data into object in the cloud and then running a cloud render. Now this render job consists of 145 frames, and it's really stressing the available CPU resources. After 5 hours, our on-prem farm has only done about a dozen frames, so we're actually going to pause that because it would take over 50 hours to complete, and we're going to move on to our cloud workflow. Now in our cloud workflow, first thing we're going to do, stage those assets using Cloud Connect into object storage. Now before we actually execute that, we're going to start our timer for our cloud workflow, and this is going to run continuously without pausing all the way from staging the data through the render. Now in the background here, you can see we're leveraging Cloud Connect to create a data link between our on-prem environment and Google Cloud. And with the link established, we're going to actually stage the assets. So we're going to move them over from the on-prem infrastructure into the cloud. And here in the background, you can see the object data has been created. You can see the object bucket that we created. That whole process took about 2 minutes. Now in this demo, again, we're staging from a single user into a single GCS bucket, but of course you can stage from multiple users as desired. And once the data is staged, we're going to spin up our cloud infrastructure for compute and Elastifile storage, and then we're going to load the data into our file system and perform our render. Now this time we're going to leverage our API-based automation, so we're going to spin up all the infrastructure in an automated fashion using Terraform. And you can see in the background here, we've begun our script. The Elastifile storage infrastructure is already spun up in the background, and now we're spinning up the compute nodes that are going to actually perform the render for our cloud-based rendering farm. And in this case, in the cloud, we're going to create a 6-node render farm, and we're going to apply 384 CPU cores to our rendering job. Now next in the background, you can see the Elastifile management UI, where you can monitor and manage the storage infrastructure. Now we're going to execute one final script to load the data from the GCS object storage into the file system so we can do the render. Now this checkout process is using Cloud Connect, but this time we're going to bypass the UI, and we're going to again leverage the REST API controls to show the automation. So we load the data into the file system and we kicked off our render in the cloud. Now, even using these more powerful cloud-based render farms, you can see the CPU resources are still saturated. But with the additional parallel resources and cores available, the cloud-based farm is executing the job much more quickly. And in the cloud, we actually finished rendering all 145 frames in under 3.5 hours, compared to the 50+ hours it's going to take with our on-prem resources, so over 10 times faster. Now with the job completed, you can now view all 145 rendered frames in our output directory located on the Elastifile file system running in the cloud, and you can see them. And in the Elastifile management UI, we can see the storage performance statistics associated with the rendering job that we just completed. These stats can be viewed in real time or after the fact as we're doing here. And you can see the different colors are showing the read and write activity, which corresponds to the data being read in for the render and the output rendered frames being written. And here you can see the fully rendered output that we created in the cloud, leveraging our expanded render farm and the additional CPU resources. So just to recap, the Elastifile solution really consists of 2 key pieces that enable these hybrid cloud workflows. The first is the Elastifile Cloud File System. It's the scale-out, distributed POSIX file system that enables those existing rendering, transcoding applications to run in the cloud without having to be refactored and without having to be rewritten. And the second piece is Elastifile Cloud Connect, which enables you to efficiently move data bidirectionally between file storage and object storage while retaining all of the file system hierarchy information and retaining all of the attributes that you would need to perform these rendering jobs once the data is located in the cloud. Now finally, just to leave you with a couple key points I want you to remember. What Elastifile is doing in these applications is making it simple to run high-performance NFS applications in GCP without having to refactor them, without having to rewrite them. We're also allowing you to tier data between performance storage on GCE, so as an example, the SSDs that would be on GCE, and the capacity storage on GCS, to allow you to dial in your performance, capacity, and cost to match your workflow and business requirements. And we're at the highest level allowing you to burst data sets to and from Google Cloud on demand without having to change your storage infrastructure, without having to change your application infrastructure, and without losing the integrity of the file data that you're processing. And with that, thank you for joining us. If you have any questions, I'm up here. Feel free to come and talk to me, and we'll be more than happy to give you more information. Thank you.